it's Mrs. Allward. Today we're going to undo our multiplication, where our division is going to come in handy. So today we're going to start talking about types of factoring. And today we're going to cover GCF, which is greatest common factor, and difference of two perfect squares. So really this is undoing our distribution, our basic distribution, and the double distribution where we were multiplying by our conjugates and those middle two terms canceled out. So these two examples down here. So let's start with this GCF. In a multiplication problem, the numbers multiplied together are called factors. The answers to a multiplication problem is called the product. For example, in the problem, 5 times 4 equals 20. 5 and 4 are factors, and 20 is the product. If we reverse the problem, 20 equals 5 times 4, we say we have factored 20 into 5 times 4. In the multiplication problem, 2x times x plus 4 equals 2x squared plus 8x. 2x and x plus 4 are factors, and 2x squared plus 8x is the product. If we reverse the problem, 2x squared plus 8x equals 2x times x plus 4, we say we have factored 2x squared plus 8x into 2x and x plus 4. Factoring expressions is one of the gateway skills that is necessary for much of what we do in algebra for the rest of the course. The word factor has two meanings, and both are important. So the two meanings of factor. The verb factor means to rewrite a given expression as an equivalent multiplication problem. The noun of factor means one of the expressions that are being multiplied to obtain a given product. So in this first box, what we're going to do is we're going to just state what the factors are and what the product is. Okay, so really the factors are what we have before we distribute, and the product is our answer after we distribute, if that makes a little bit more sense. So in A, our factors are over here. So it's going to be 5 and the x minus 7. Make sure you have the x minus 7 in parentheses. It's really, really important. And our product is that final answer over here, the 5x minus 35. So in our second example, our factors are the 3x and the x plus 9. Again, make sure it's in parentheses because it is in the example. And our product is that answer at the end after the distribution, 3x squared plus 27x. The first step in factoring polynomials is to factor out the greatest common factor, or GCF. This is the largest integer and highest degree of each variable that will divide evenly into each term of the polynomial. Factoring is the reverse of multiplying. Okay, so in the polynomial 5x minus 35, 5 is the largest integer that will divide 5x and 35, and we cannot factor out any variable because the second term, 35, does not have a variable part. To factor 5x minus 35, we write 5x minus 35 equals 5, and then in parentheses, x minus 7, because this is what we would have if we wanted to distribute and go back to the 5x minus 35. In the polynomial 3x squared plus 27x, 3 is the largest integer that will divide 3x squared and 27x. We can factor out x because each term has at least one factor of x. Look for the term with the lowest degree of each variable. So to factor 3x squared plus 27x, we write 3x squared plus 27x equals 3x, and then in parentheses x plus 9, because this is what it would look like before we distribute to get this product. So we're going to practice that. So once you can identify the greatest common factor of a set of monomials, you can then easily use it and the distributive property to write equivalent factored expressions. So we're going to write each polynomial below as a factored expression involving the greatest common factor of the polynomial. So what I like to do is set it up like a division problem, but really that division isn't going anywhere. So first thing that I want to look for is what is the largest integer that will divide into the coefficients, and then what is the smallest exponent, okay, for all terms. So we have 6x squared plus 10x. So out of 6 and 10, the largest integer that divides evenly into it is 2. So I'm going to make myself a little division problem. So I'm going to have 2. And each term has an x, so I look at my exponents. That's 2. This is the invisible 1. So the most I can take out is one of these x's. So I'm going to divide by 2x into each term. But that's not really going away. I'm just factoring it out. 2x is one of my factors. And when I divide it out, what's left over is my other factor. So 6 divided by 2 is 3. X squared divided by x is x, plus 10 divided by 2 is 5, and x divided by x, they cancel out, and that's what we're left with. So if we were to distribute 2x to 3x plus 5, we would end back up at 6x squared plus 10x. Let's try the next one. We have 3x minus 24. So we have 3 and 24, and I know that 3 can divide evenly into 24, so I can divide by that. The 24 doesn't have an x, so I can't take out a variable. So my GCF is 3. 3x divided by 3 is just x, minus 24 divided by 3 is 8. So 3 times x minus 8 are my factors. C. 10x squared minus 15x. So 10 and 15, I know I can divide a 5 out of each of those. I have an x squared and an x, that's my invisible 1, so I can take an x out of each of those terms as well. So my greatest common factor is 5x, and then we divide. 10 divided by 5 is 2, x squared divided by x is x, minus 15 divided by 5 is 3, and my x's cancel out. And that's it. So let's try some trinomials. Remember, a trinomial has 3 terms. So now our GCF has to go into all 3 terms. 4x squared plus 8x plus 24. So I know all 3 terms can be divided by 4. But all 3 terms do not have an x, so I can't take an x out of each of them. So I'm just going to divide by 4, and 4 will be my GCF. So the 4's cancel. I'm left with x squared. 8 divided by 4 is 2, and I bring the x with it. And 24 divided by 4 is 6. And I'm done. E. 6x cubed minus 8x squared plus 2x. So 6, 8, and 2, I can divide all those terms by 2, and they all have an x. 3, 2, and invisible 1, I take that lowest exponent, so I can take an x out of everything. So 2x is my GCF. So 6 divided by 2 is 3. X cubed divided by x is x squared, minus 8 divided by 2 is 4. X squared divided by x is x. Now something interesting happens over here. 2 divided by 2 is 1. X divided by x cancels. So when this last term when the whole numerator and the whole denominator are the same, they don't just completely cancel out and go away. The whole thing equals 1. It starts as a trinomial. It must end as a trinomial. Let's look at f. We have 10x cubed minus 35x squared. So 10 and 35, I can divide 5 out of each of those. And then I have x cubed and x squared. My smallest exponent is x squared, so I can take an x squared out of each of these terms. So 5x squared is my GCF, and then I can divide. 10 divided by 5 is 2. X cubed divided by x squared is just x, minus 35 divided by 5 is 7, and the x squareds cancel. Last row of GCF, and then we'll talk about difference of two perfect squares in the second half of the video. 10x squared minus 40x minus 50. All of these numbers are divisible by 10. And since the 50 doesn't have a variable, we can't take a variable out. Now, other numbers could go in. We could divide by 5, we could divide by 2, but we want the greatest number, the largest number that can go into everything. That's why 10 is the key. So we end up with x squared minus 4x minus 5. H, 8x to the fourth minus 2x squared. 8 and 2 are both divisible by 2. They both have x terms. We go with that smaller exponent so we can divide by x squared. 2x squared is our GCF. And we divide. 8 divided by 2 is 4. X to the fourth divided by x squared is x squared minus, and then we have that situation in H here like we did in E, where the numerator and the denominator are exactly the same. So we're going to have a minus 1 at the end. And our last GCF, we have 8x cubed plus 24x squared minus 32x. So we have 8, 24, 32. We can divide 8 into all three terms, and they all have a variable. We take that smallest exponent, so we're going to divide all terms by x. So 8x is our GCF. So in the first term, our 8's cancel. X cubed divided by x is x squared, plus 24 divided by 8 is 3. X squared divided by x is x, minus 32 divided by 8 is 4, and our x's cancel. So that is GCF, or greatest common factor. So hold tight and go on to the second half of the lesson video for difference of two perfect squares, and we will finish up the notes. Thank you very much. See ya in just a second.